We'll do collision, note down. Collision, okay. Explosion means we discussed in explosion what happens. Breakup. Explosion means breakup. When one object breaks into two or more fragments. Okay. One object breaks into two or more fragments. Okay, that is explosion. What is collision? Two or more objects or particles, two or more objects or particles come close to each other, come close to each other. Explosion means initially there was one object. Initially there is one object. It is breaking into fragments, correct? Like gun and bullet. So suppose this is the gun and this is the bullet. Bullet is inside the gun. So it is one object. It is one object. But when you fire the this bullet, when you fire it, what happens to bullet? Where bullet will go? Right side. And where the gun will go? Left side. So we can say one object is breaking into two objects. Okay, understood? Same thing happens in nucleus also. Like uranium, nucleus is there 92 uranium 235. It breaks into some X nucleus and alpha particle, correct? Uranium is breaking into X and what is the mass number of alpha particle? 4. Okay, so you can say this is a yes 231. So uranium 92 uranium 235 breaking into some other nucleus whose mass number is 231 and alpha particle whose mass number is 4. Are you getting? So initially uranium is at rest. If alpha particle is going right side, so this X nucleus will go where? Left side. Okay. So this is also explosion. Breaking up of one object into two or more fragments. Correct. So let's solve. Let's discuss both together. Explosion also and collision also. Okay. So this gun and bullet we have discussed yesterday, previous class. Gun and bullet. Something at rest, breaking into two parts. One part is going right side, other part is going left side. Okay, that is explosion. Now, what is collision? Two or more objects come close to each other. Okay, but what is common in both? What is common in both? Internal forces. Internal force is common. What is internal force? Internal force. What is internal force? If you look at this gun and bullet, this is the gun, this is the gun, and this is the bullet. Gun and bullet. So some internal process is going on. Internal process is going on. Chemical reaction is going on. Okay. So gun is throwing bullet where? This side. So gun is exerting force on the bullet, right side, right side. So bullet will exert force on the gun, left side. Okay. So that force is external or internal? Internal, correct. Internal force. Okay. So if you want to draw the diagram of internal force, you can draw like this. So force on the bullet is right side, force on the gun is left side. Okay, these are internal forces. If you consider this as a system, if you consider this as system means group. System means group. System means group. Like suppose uh, one house is there, one house. Okay, this is house number A, house A. Okay, some members are living in this house. Okay, some members are living in this house, and there is another house B. There is another house B. Some members are living in this another house B also. Okay, B is hearing some noise, something going on in house A, maybe. Okay, some fighting going on, maybe. So house B, people will say, no, it is their internal matter. Correct or not? Why we should, right or not? Why we should go and check? It is their internal matter. Right? So, because this is a system. This is a system. Internal forces are there. Correct? If house B member is also going to house A, then situation will be more worse. Worse means not good. If they can solve internally all their matters, they can solve internally, then problem is less, solution is better. Understood? So like that. So now I am going to physics. So now gun and bullet, some chemical reaction going on. So gun is exerting force on the bullet, right side. So bullet is also exerting force on the gun, left side. So what type of force is that? Internal force. Okay. Internal force. So when you consider this as system, internal force cancel each other. See, the force on the bullet is where? Right side, and force on the gun is where? Left side. So net internal force. What is net internal force? Zero. Note down. Net internal force in a system. Net internal force in a system is zero. Net internal force in a system is zero. So that's why momentum is conserved, because we know that net force is equal to dp by dt, but this is the net force on the system. Net force on system. And what is p here? What is p here? Momentum of system. Momentum of system. Okay, if you write in vector form, you can write like this. Okay, so f vector is equal to dp vector by dt. So net force on system is equal to dp by dt, but what is p here? Momentum of system. Okay, system means more particles are there. So now when you say net force, some forces may be external, some forces may be internal. So we can say external force plus internal force is equal to dp vector by dt. But if there is no external force, then what is the net force? Net force means sum of external and internal. If external is 0, then internal, we know that internal is also 0, because net internal force is what? 0. So what is the total force? What is the total force? 0. So 0 is equal to dp vector by dt. It means what? P vector is constant. P vector is constant. So this is known as conservation. Okay, this is known as conservation of linear momentum. This is known as, note down, conservation of linear momentum. What is the condition when momentum is conserved? Conserved means increasing, decreasing at the same time. Increasing, decreasing at the same time. Like conservation of water, you are taking water, then river will come, rain will come, rain will fill the water. You are cutting two trees and growing two trees. Okay, so number of trees fixed. So conservation. Okay, something increasing but another thing decreasing. So balance is there. Okay, so conservation of momentum. What is the condition for it? Tell me. No, no external force. Good. No external force. And internal force is always cancelled. So net internal force always 0. Okay. So you can say P initial is equal to P final. Suppose there are two objects. There are two objects. So initial momentum of first plus initial momentum of second is equal to final momentum of first plus final momentum of second. Correct? Suppose two objects are there. If only one object is there, so we will say initial momentum is final momentum, but suppose two objects are there, so separately you have to consider. Consider separately. Okay. So basically, this is known as conservation of linear momentum. Momentum before and after same. Before and after what? Before and after what? It explosion or collision. Okay, because in explosion two objects go away from each other, but collision two objects come close to each other. So note down this, sir. Now, so this is our topic today, collision. Okay, two or more objects or particles come close to each other. They come close to each other. Okay, and what is common in both collision and explosion? What is common? Internal forces. Okay, so what type of internal force in explosion? Push. It is like a push. They are throwing it away. Correct. Gun is throwing bullet away. But what type of force, internal force in collision? Huh? Okay, we'll discuss. We'll discuss. Okay, you observe it carefully. What is collision? Imagine there is a ball. Mass of this ball is m1. Another ball of mass m2. m2 is coming left. m1 is going right. And these are the centers of the ball. These are the centers of the ball. Okay. These are the centers of the ball. If you join these centers with a line, then what you call this line? Line joining centers. Line joining centers. Okay. These are spherical balls. These are spherical balls. Okay. Small. Radius is small. Okay. Radius can be large also, no problem. These can be like this also. This radius is large, this radius is less. Okay, no problem. Like this also possible. Okay, so m1 is going right side, m2 is going left side. The velocity of m1, the velocity of m1 is u1, and the velocity of m2 is u2 left side. Okay, so you can say these are speeds. What is the speed of m1? u1 right side. What is the speed of m2? u2 left side. And these speeds are along line joining. These speeds are along line joining. Okay. What if this is the line joining, but velocities are not along line joining? Suppose this is this is here, maybe the velocity of this object is this way, velocity of this object is this way. It means u1 vector, u2 vector, okay. The velocities are not along line joining centers. What is the difference you see in these two? The two balls are approaching each other. The velocities are along line joining. Here also, two balls are close to each other, but the velocities are not along line joining. Okay, this is line joining. Okay, so you remember this is known as head-on collision. This is known as head-on. What do you mean by head-on collision? What do you mean by head-on collisions? The initial velocities are along line joining. Head-on collision means if initial velocities are along line joining centers. Initial velocities are along line joining their centers. This is known as head-on. Okay. So first you understand head-on collision. Then what you call this type of collision? This is known as oblique. Okay. This is known as oblique collision. What is oblique collision? Oblique collision, if initial velocities are not along line joining centers. Note down, if initial velocities are not along line joining centers. If initial velocities are not along line joining centers, that is known as oblique collision. Fine. So let's take some example. So note down these diagrams. M1 and M2, they are approaching each other. So this is approach. Okay. Approach means coming close. Approach means coming close. So velocities are along line joining. Okay. Then what will happen? If they are coming close, what will happen? Collision will happen. Correct. Collision happens means what? What will happen? Force. They exert force. Now two balls are coming close. So they will come in contact. The two balls come in contact. So this is suppose ball 1 and this is ball 2. So force, they exert force. So they exert force on each other. So one will exert force on 2. Where? This is force on 2 due to 1. Right side. Good. And 2 will exert force on 1 where? Left side. So this F12. F12. So they deform. Okay. Because these balls are made of some material. Okay. Materials is not rigid. All materials little bit they are elastic, not rigid, like tennis ball. Okay, tennis ball is flexible, correct? So they deform each other. So the shape of the ball will change like this. Shape of the ball will change like this. Okay, from spherical to this shape. Okay, this is not spherical. Then what will happen? The shape will deform to maximum. Okay, maximum. Now maybe the shape will be like this. Maximum deformation. Maximum deformation. Then again it will regain their shape. Then again shape will change like this. Then again the shape will become spherical. Okay. After this spherical shape, their velocities will be different. Now separation is there. Okay. So you can observe what is going on in this collision. Initially they are coming close to each other, then they are hitting each other. This is coming close to each other. So force on 2 will be right side, force on 1 will be left side, correct? So you take tennis ball, if you exert force from both sides, the shape of tennis ball will change like this, correct? So some energy is stored in this. Some energy when they deform, this is known as deformation. So what energy is converted into what other energy? Kinetic energy is lost. Kinetic energy is lost during deformation and convert into potential energy, elastic potential energy, note down, and convert into note down. In during deformation, what happens? Kinetic energy, some kinetic energy is lost and it is converted into elastic potential energy. Okay, so note down. And some heat is also released, maybe. Okay, some heat also produced. Now we cannot recover that heat that is lost, but elastic potential energy we can recover. Okay, so what is going on? Initially, what type of energy they have? They are moving like this. What type of energy? Kinetic energy. They have kinetic energy. Then when they are deforming, what energy is increasing? Elastic potential energy. And what energy is decreasing? Kinetic energy. So you can say kinetic energy is equal to potential energy plus heat. Potential energy plus heat. Potential energy plus heat. Sometimes heat is not there, only potential energy, elastic. So elastic potential energy plus heat generated. Heat generated. Okay. So then they are again separating. So when they are separating, what happens? When they are separating, what happens? Potential energy again convert into kinetic energy. Potential energy again gets converted to kinetic energy. But the heat is there, so this kinetic energy will be less. This kinetic energy will be less as compared to this kinetic energy. Like what is the kinetic energy here? Tell me. What is the kinetic energy here? Half m1 u1 square plus half m2 u2 square. And suppose finally after separation they are going with v1 and v2, then what is the final kinetic energy? Half m1 v1 square plus half m2 v2 square. This is the final kinetic energy, correct? So which is more, initial kinetic energy or final kinetic energy? Initial kinetic energy or final kinetic energy? Which is more? Tell me. Initial is more because some heat is generated in the process of collision. Okay. So this type of collision is known as inelastic. Inelastic collision, kinetic energy is lost, okay, because of heat. Due to heat, kinetic energy is lost. Note down. In inelastic, okay, you write like this: inelastic. It is a one word. It is a one word. Okay, inelastic collision. You can write like this: in inelastic collision, kinetic energy is lost due to heat. So when kinetic energy is lost during collision, kinetic energy is lost. What you call that type of collision? Inelastic. Okay. So what is perfectly inelastic? What is perfectly inelastic? What do you mean by perfectly inelastic? Maximum kinetic energy is lost. Maximum kinetic energy is lost. Okay. Maximum kinetic energy loss means you call it perfectly inelastic. And you write one more word. The particles stick with each other. Particles stick with each other. Particles stick with each other as a single body. Particles stick with each other as a single body. Like for example, you take a ball, release it, it is hitting the mud. Suppose mud is there, rain is there, okay, rain is there, all mud is there, mud is there. Okay. Now you drop a ball, it will rebound or not? No, it will not rebound. So, we can say the ball is sticking with the mud. Ball is sticking with the mud. Okay. So they go like this. Suppose these are the two objects. Suppose these are the two objects. They are going like this. Okay. They stick. Now they stick. They are going together. Okay. They are going together. Initially, this is one object. This is other object. But after collision, they are together. Okay. So they stick. Particles stick with each other. What type of collision is that? Perfectly inelastic. Perfectly inelastic. Okay. Inelastic means kinetic energy is lost. Perfectly inelastic means maximum kinetic energy is lost. Maximum. Okay. Then there is another type which is known as elastic. Perfectly elastic. Note down. Perfectly elastic collision. Kinetic energy is not lost. Heat is zero. Kinetic energy is conserved. Kinetic energy is conserved. Kinetic energy is not lost. Kinetic energy is not lost. Okay, this is perfectly elastic collision. So perfectly elastic collision, kinetic energy is conserved during collision. Kinetic energy is conserved during collision. Okay. So inelastic collision, kinetic energy lost. Maximum lost in perfectly inelastic. Objects stick with each other. Remember, very important point. Objects stick with each other. Now perfectly elastic collision, kinetic energy is conserved, kinetic energy is not lost. Heat produced is zero. Perfectly elastic collision. Okay, so three types of collision. Three types of collision. Now let's talk about forces. Once again, I will talk about forces. Then we'll do some formula. So during collision, what is going on? Two balls are coming close. So they are exerting internal force. This internal force acts for more time or less time? Less time. Like football is there. So football is there. You are hitting the football. Okay. Suppose you are hitting the football. You are okay. You are hitting the football. The leg of person and football comes in contact. Football goes in air. So player is also goes in air. A player is on the ground only. It is ground. The contact come for more time or less time? Less time. So football will go in air after that. So this is also collision. Correct? So collision means what? The internal force acts for more time or less time? Less time. Okay. So generally, most of the time, it is like this. Okay. And note down. Two points you write down. Two more points you write down. In collision, internal force acts for short time, very short time. In collision, internal force acts for very short time. Okay, to one point you write down this. Second point you write down, for collision, contact is not necessary. For collision, physical contact is not necessary. For collision, physical contact is not necessary. Okay, note down. These 2 points also you write down. In collision, internal forces acts for very short time. For collision, physical contact is not necessary. Physical contact is not necessary. We have two examples. One example we have taken, okay, for collision, physical contact is there like this. Physical contact is there, two balls coming, they will hit like this, they will hit, then again separate, correct? So physical contact is there. But we have one more example in which physical contact is not there. Gold foil experiment. So Rutherford performed this. So gold foil experiment is there. So alpha particle is coming. So alpha particle is coming with speed u. So what is the charge on alpha particle? You just tell me nature of charge, plus or minus? Plus. So alpha particle is positively charged. Gold nucleus is also positively charged. Positively charged. Okay. Gold nucleus. Okay. So both are positive, but the velocity of alpha particle is towards gold. Correct. So when alpha particle is here, the velocity will be less. Velocity will decrease. Why velocity will decrease? Because force is where? Left. This alpha particle, the force will be left because positive repel. So force is opposite to velocity. So the velocity is decreasing, correct? So ultimately the alpha particle come to rest. Alpha particle come to rest, but it is not touching the gold nucleus. Contact is not there. Are you getting? What do you call this minimum distance? What do you call this minimum distance? Distance of closest approach. Distance of closest approach. Okay. So they are approaching, but they are not touching each other. Okay, they are approaching and come to minimum distance. That is known as distance of closest approach. Then again, alpha particle will go left side. Then it will go there. Okay, but they are not touching each other. Okay, clear? So physical contact is not necessary. So can I say this is collision? This is collision. Yes, this is collision because what type of force is there? Internal, positive, positive charge, repel. What type of force? External or internal? Internal, okay, internal. So this is also collision, okay. The interaction of alpha particle and gold nucleus is also collision, but physical contact is not there without, okay. So sometimes collision have physical contact, sometimes it does not have physical contact. So for collision, physical contact not necessary, okay, note down. Physical contact not necessary. For collision, physical contact not necessary, okay, clear? Okay. These are given in books also. If you study NCERT books, okay, DC Pandey also it will be there. Okay, fine. So these are some theory points. Now, one topic you write down: head-on collision. Head-on collision. So draw these diagrams. So u1 and u2. What is the velocity of first object? u1. Second object? u2. So they will collide. They will collide. So what they are doing? They are approaching or they are going away. Which is greater, u1 or u2? u1. So it is like this. It is like this. Okay. They are coming close. Then again they will separate. Okay. Then they will separate. So suppose this is after collision. It is v1 and v2. Now v2 is greater than v1. So this is before collision. This is before collision, and this situation is after collision. Okay, clear? So before collision, what is going on? Whose velocity is more, 1 or 2? Whose velocity is more, 1? After collision, whose velocity is more, 2? So this is known as approach. This is known as approach, and this is known as separation. This is known as separation. They are going away. Separation. Okay, they are coming close. Okay, so approach. So what is the relative velocity? Tell me, what is the relative velocity? u1 minus u2. And what is the relative velocity here? v2 minus v1. Magnitude. Okay, magnitude of relative velocity of approach. Magnitude of relative velocity of approach is u1 minus u2, and this is magnitude of relative velocity of separation. Relative velocity of separation is v2 minus v1. So u1 u2 v1 v2, just think like this, u1 greater, v2 greater. So we have a formula for E. Now what is E? You know this value. What is this? Coefficient of restitution. Restitution. Okay, coefficient of restitution. Okay, clear? What is the symbol for that? E, small e. This is capital E, this is a small e. Okay, small e is the symbol. Small e. So it is given by this divided by this. Velocity, relative velocity of separation divided by relative velocity of approach. Note down, this is the formula. So I will revise again these topics later, but time is less, so important points we are discussing. Okay, maybe some other time I will take. Okay, uh, what do you mean by this? Okay, I will explain. But right now you just write down for perfectly elastic collision. For perfectly elastic collision, E is equal to 1, and perfectly inelastic collision, E is equal to 0. What is perfectly inelastic collision? Maximum loss of kinetic energy. Very good. Perfectly elastic collision, 0. 0 loss of kinetic energy. Okay. So for other type of collision, the value of E is between 0 and 1. Other type. For inelastic. So the E value is maybe 0.2, okay, E value may be 0.8, E value can be 0, E value can be 0, E value can be 1, E value can be 1 by 2, okay, E value can be 1 by 3 like this, okay. So 1 by 3, 1 by 2, they are less than 1, 0.2, 0.8 less than 1, correct. So this is coefficient of restitution and the conservation of momentum is there. So P initial is equal to P final. So what is P initial? M1 U1 vector plus M2 U2 vector, and what is P final? M1 V1 vector plus M2 V2 vector, okay, note down. So these two formula you remember. And what is initial kinetic energy? Initial kinetic energy of system, that also you know already, we have seen, we have written half M1 U1 square plus half M2 U2 square. When U1 U2 are there, what is final kinetic energy of system? Half M1 V1 square plus half M2 V2 square. This is the final kinetic energy. Okay, clear? Remember this. So momentum is vector. Momentum is vector. Remember, momentum is vector. Okay. So sometimes we will have to consider I cap, J cap also later. Okay. So momentum initial is equal to momentum final. Not all. Kinetic energy of system initial kinetic energy, final kinetic energy, they are equal. Initial kinetic energy and final kinetic energy are equal in perfectly elastic. Perfectly elastic means K initial is equal to K final. But K initial is greater, K final is less. K initial is greater than K final in perfectly inelastic and inelastic also. K initial is greater than K final. So kinetic energy is lost, okay, because kinetic energy is lost. Kinetic energy is lost. So let's revise once again. So you have masses are given M1, M2. So M1, M2, two balls are there. They are coming close to each other. Maybe they are going like this or they are going like this. Okay. If velocities are right side, so you take positive. Left side means negative. Remember, right side means positive. Left side means negative. Okay. So this is head-on collision. So before, after, before U1, U2, after V1, V2. So what is the formula for E? V2 minus V1 by U1 minus U2. Okay, memorize this. And initial momentum and final momentum are same. And initial kinetic energy is this formula, final kinetic energy is this. If perfectly elastic means initial and final kinetic energy are equal. Perfectly inelastic and for inelastic, which is more? Initial is more. Initial kinetic energy is more than final because kinetic energy is lost. Kinetic energy is lost. No kinetic energy is lost in perfectly elastic. Kinetic energy loss is zero. Loss in kinetic energy is zero. In which type of collision? Perfectly elastic. Okay, fine. So let's do perfectly elastic. Note down. Topic you write down. Perfectly elastic. Identical masses. Identical masses. Masses are equal. Perfectly elastic for identical masses, balls or particles. Two particles have same mass. So what happens, let's find out. So suppose the mass of each is m. First is going with u1, second is going with u2. Now u1 is greater than u2, fine, and this is the line joining. Now after, what is the velocity v1 and v2? Okay, fine. Now perfectly elastic means what is the value of e? 1. E is 1. So v2 minus v1 by u1 minus u2 is equal to 1. So v2 minus v1 is equal to u1 minus u2. v2 minus v1 is u1 minus u2. Fine. So this is first equation. Note down. Because E value is 1. Masses are same. Okay. Masses are identical. If this is 1 kg, this is also 1 kg. This is 1 gram, so this is also 1 gram. Same mass, identical. First equation, v2 minus v1 is equal to u1 minus u2. Second equation, you write down momentum conservation. Momentum conservation. So what is the momentum of particles before collision? This is before and this is after. So before collision and after collision, tell me. Before collision, what is the momentum? Tell me before collision. mu1 plus mu2. After collision, mv1 plus mv2. Okay, masses are cancelled. So now you have one more equation here. v1 plus v2 is equal to u1 plus u2. Now two equations we have. So you write v1 plus v2 on the left side. v1 plus v2 is equal to u1 plus u2. Okay, mark this as second. So v2 minus v1 is u1 minus u2 and v1 plus v2 is u1 plus u2. Okay, now solve this. How to solve? We have to find v1 and v2. Okay, solve. How to find v1 and v2? Add. If you add these two, left side, what is there left side? v2 minus v1 plus v1 plus v2. Okay, solve by adding. Solve. So what you get? 1 and 2 you add. 1 and 2. Add. What you get? Tell me. 2v1. Sorry. 2v2. Yes, correct. 2v2 is equal to, now here u1 minus u2 and u1 minus u1 plus u2. So 2u1. Again 2 to cancel. That means v2 is equal to u1. v2 is equal to u1. Now find v1. So use first equation. Using first equation, v2, you substitute v2 as u1. u1 minus v1 is equal to u1 minus u2. Now u1 cancel. So minus v1 is equal to minus u2. Minus minus cancel. So v1 is equal to u2. Okay. v1 is equal to u2. Okay. See. What type of collision is this? What type of collision? Perfectly elastic. Okay. Perfectly elastic and masses are identical. Same mass. M. Masses are same. So first equation using E formula, E is equal to 1. v2 minus v1 is equal to u1 minus u2. Second equation using momentum conservation, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Two equations you have. These two equations, solve this. Okay, clear? So v2 is equal to u1, v1 is equal to u2. So they interchange their velocities, note down. They exchange or interchange. They interchange their velocities. They interchange their velocities. V2 becomes U1 and V1 becomes U2. So they interchange their velocities. For your reference, you can draw this diagram. Suppose first is going with 1 meter per second, second is going with 0.5 meter per second. This is before collision. This is ball A, ball B, ball A, ball B. After collision, tell me what is the velocity of ball A? 0.5. So ball A will go with 0.5 and ball B will go with 1. Okay, 1 meter per second. So they interchange their velocities. Okay, one more example you can write. Suppose ball A is going right side with 1 meter per second and the ball B is going left side with 2 meter per second. So this is before collision and after collision. After collision, tell me what are the velocity? What is the velocity of A? Before collision, A is going 1 meter per second right side, B is going 2 meter per second left side. So after collision, what is velocity of A? Interchange. 2 meter per second left side. What is the velocity of B? 1 meter per second right side. Okay, 1 meter per second right side. Okay, so remember this. Okay, so they interchange their velocities in perfectly inelastic collision. Masses are same. When masses are same, then only. If masses are not same, then no interchange. Remember, what is the condition that they interchange velocities? What is the condition? Masses are same and collision what type? Collision what type? Perfectly elastic collision. Okay, good. Perfectly elastic collision. So, like for example, give me book. I will give one question based on this. You have book. So page number I will give. So note down. So perfectly. So this is collision chapter is where? System of, I think center, yeah, center of mass and collision. Okay, center of mass and collision. This is the next chapter. Yeah, one question is there, page 399. It is a PYQ, 10th question. So two balls A and B, two identical balls. Identical. Identical means same mass. Mass same. Two balls A and B have velocities 0.5 and minus 0.3. Means A is going where? Right side with 0.5. B is going where? left side with 0.3, okay, minus 0.3, collide elastically in one dimension, means straight line. So what are the velocities of A and B? Sorry, B and A. What are the velocities of B and A after collision? What is, first you tell me B. What is the velocity of B after collision? 0.5. And what is the velocity of A after collision? 0.3 left. So your answer is 0.5 comma minus 0.3. Now let's solve 8th question. So identical masses means they interchange their velocities. Okay, perfectly elastic. Perfectly elastic. Now what is 8th question? Look at 8th question. Come to 8th question. Body A of mass 4m. Body A of mass 4m. Let's draw like this. Body A of mass 4m. Okay. It is going with a speed u. It is going with a speed u. Another body of mass 2m at rest. So body B is at rest, but mass 2m. So you tell me what is u1? What is u1? U. And what is u2? 0. Very good. So this is before collision. This is before collision, and collision is head on and elastic in nature. Collision is head on and elastic. Elastic means perfectly elastic. So after collision, you tell me with their velocities. Tell me what is the velocity of 4m? It is perfectly elastic. So what is the velocity of 4m? Oh, sorry, masses are not same. We cannot solve like this. You write the equations. So velocity of 4m is v1 and velocity of 2m is v2. Can I say they interchange their velocity? Can I say? No, because masses are different. Okay, now you solve using equations. Solve using equations. First you write E formula. What is E formula? V2 minus V1 by U1 minus U2. Okay, find V1 and V2. Find V1 and V2 first. Okay, E is 1 because it is elastic, perfect elastic. So V2 minus V1 is U1 minus U2. So V2 minus V1 is U. Okay. Now momentum conservation. You do momentum conservation. 4m into U plus 2m into 0 is equal to 4m V1 plus 2m V2. Cancel. So 4u plus 0 is equal to 4v1 plus 2v2. Now divide by 2. So 2u is equal to 2v1 plus v2. This is clear, everyone? Okay. Carefully you have to solve. Okay. Slowly you solve, no problem. But no silly mistake. Okay? I divide by 2. So 2u is equal to 2v1 plus v2. Okay. Now this is the second equation. Now you write both equations. I am writing both equations here. So V2 minus V1, V2 minus V1 is equal to U, and 2V1 plus V2 is equal to 2U. First equation, second equation. Now add. When you add, what you get? Add. Okay, no, wait. Don't add. Subtract. Not add. Subtract is better, correct? This is first, this is second. So 2 minus 1. 2 minus 1. 2 minus 1. Tell me. This minus this. 2V1 plus V2 minus V2 minus V1 is equal to this minus this. 2U minus U. So 2V1 plus V2 minus V2 plus V1 is equal to U. Now 2V1 plus V1, 3V1. So 3V1, V2 cancel is equal to U. So what is V1? U by 3. V1 is U by 3. And what is V2? V2 is equal to V1 plus U. So U by 3 plus U. U by 3 plus U how much? 4U by 3. Very good. 4U by 3. Now what is the initial kinetic energy of 1? Initial kinetic energy of 1. 1 is going with, this is 1. This is 2. So what is initial kinetic energy of 1? Or you can say A also, no problem. What is the initial kinetic energy? Half 4m U square. So initial kinetic energy of A is equal to half 4m U square. What is final kinetic energy of A? What is final kinetic energy of A? Tell me. What is final kinetic energy of A? Tell me. Half 4m V1 square. Are you getting? Means this is before collision. Initial means before collision. After collision means final. After collision, what is the kinetic energy of A? Half 4m into V1 square. So half 4m into U square by 9. Okay. Now what is the question? Read the question. After the collision, the fraction of energy lost by colliding body A. After the collision, the fraction of energy lost by colliding body A. After the collision, fraction of kinetic energy lost by A. So means they are asking fraction lost. What is the fraction of lost? Suppose you have 100 rupees. You have 100 rupees. You have spent 20 rupees. 20 rupees you spent. How much left? 80 rupees left. So how much lost? 20 rupees. So what is a fraction lost? Fraction lost means lost divided by original. Lost divided by original. How much original? 100 rupees. You have 100 rupees, 20 you spent. How much lost? 20. So fraction lost means lost by original. So what is the answer? 20 by 100. 20 by 100 how much? 0.2. 0.2. Okay. So this is known as fraction lost. Okay, if you multiply it by 100, you will get percentage. Percentage fractional lost. Percentage of fraction loss. So 0.2 into 100. So what is the answer? 20%. Remember this. So when I say fraction lost, so lost by original, remember. Now you calculate here. How much is lost? Calculate here. You solve this. This is 2m u square. And how much is this? 2m u square by 9. So how much is lost? Tell me lost. Initial kinetic energy of A minus final kinetic energy of A. Tell me. 2mu square minus 2 by 9 mu square. Solve this. 2mu square common. 1 minus 1 by 9. 2mu square common. 1 minus 1 by 9 how much? 8 by 9. So what is the answer? 16mu square by 9. So this is the lost. This is the lost. So what is the fraction lost? What is the formula for fraction lost? Lost by original. So this is the lost. So 16 mu square by 9 divided by original 2mu square. 2mu square. Okay. So this 16 by 2 8. 16 by 2 8. 8 by 9 mu square cancel. Okay. mu square cancel. Okay, clear? So fraction loss means 8 by 9. Note down. Fraction loss means 8 by 9. So fraction loss means loss by original. Loss by original. Note down. And okay, fine. So we have discussed enough. I am looking for one more question. So let's solve one question on explosion. 7th question. Okay. Okay, fine. So initial kinetic energy of A, final kinetic energy of A. Okay. Calculate, find loss. Loss means initial minus final. Initial minus final. That is loss. Then you calculate fraction loss. Fraction loss means loss by initial. Loss by initial. 8 by 9. Fine, clear? Now come to 7th question. 7th question is collision or explosion. 7th question is collision or explosion. It is particle of mass 5m. Particle of mass 5m suddenly breaks. Suddenly breaks means it is collision or explosion. Explosion. Into how many fragments? 3 fragments. 2 fragments of mass m each move along mutually perpendicular. You can take these 2 fragments. What are their velocities? Mutually perpendicular. So you can assume this is at rest. It is given in the question, it is at rest. Now these are the 2 fragments. Their velocities are perpendicular. So one you can take j cap, another you can take I cap. And this third fragment we don't know. So you can assume the third velocity v3 vector. The velocity of third we don't know. So you can assume it to be v3 vector. But other two you know Vi cap and Vj cap. What is the energy released? What is the initial energy? Energy means kinetic energy. So what is the initial kinetic energy? 0. Initial kinetic energy is 0. What is kinetic energy of this? Half. Masses are these masses are m, and this is 3m. It is given in question. Read the question. Two fragments of mass m move mutually perpendicular, and what is the mass of third? Total is 5m. So third will be 3m. So what is the kinetic energy of this? Half 3m. V3 square. What is the kinetic energy of this? Half m v square. What is the kinetic energy of this? Half m v square. So what is total kinetic energy? Total. Tell me. Total kinetic energy released. Total kinetic energy. Tell me. Add half 3m v3 square plus half m v square plus half m v square. Okay, clear? So this is the total kinetic energy released. Now momentum conservation you do. So momentum conservation, how you solve? What is initial momentum? Rest. 0. What is momentum of this? It is v3 vector. Okay. So 3m into v3 vector. What is the momentum of this? mv j cap. What is the momentum of this? Plus mv I cap. So now this will be 0 vector is equal to 3v3 vector plus vj plus vi. So you will write 3v3 is equal to, okay, you can write like this, minus vj minus vi is equal to 3v3. So what is 3v3 vector? Minus v common, I plus j. So what is v3? Minus v by 3 into I plus j, correct? Minus v by 3 into I plus j. What is the magnitude of this? Find magnitude. You know what is the magnitude of I plus j? What is the magnitude of I plus j? I plus j? Correct, root 2, very good. Square root of 1 square plus 1 square. So square root of 1 plus 1, so root 2. So this will be minus v by 3 into root 2. Then you can put it here. So total kinetic energy release you will get v3 square here. So v3 square means magnitude square. So v by 3 root 2 square. V by 3 root 2 square plus half mv square plus half mv square will be mv square. So 3m by 2 into v square into 2 by 9 plus mv square. Are you getting? You solve this question once again. 2 to cancel. So 3 by 9 how much? 1 by 3. 1 by 3 mv square plus mv square. 1 by 3 plus 1 how much? 1 by 3 plus 1 how much? 4 by 3. Okay. So this is the energy released. Total kinetic energy released. Okay, now you take break. 9:10, huh? 9:20. 9:20, 1 more hour I will teach. Okay, not now. Then okay, you continue. Anyway, you don't have other classes. Okay, okay, fine. So you be ready. Okay, Sunday also be ready because we have to finish syllabus by November. Because you should have free time also after your November. You should have free time. Free time means self study. Okay, if syllabus is not finished, again extra classes, you get disturbed. Okay, so Okay, so you be ready. Sunday also you ready. Okay, Saturday also you ready. If possible, we will take class all 7 days. If possible, okay. All 7 days classes. Sunday, if possible. Otherwise, at least 6 days we will take. Okay, fine. Now you take break.